Okay, let me introduce our second presenter, Steve Watts. Steve is a cost consultant and leads the firm's global tall building group, Davis Langdon, which is in UK. And Steve has been the UK country leader of the CTBUH for many years. Okay, let's welcome Steve.
Yes, I am a cost consultant, but I like to think that I think more than just about costs, although sometimes I can't help myself. And yesterday I was wandering down the wall there looking at all the student proposals, some of which, in fact all of which are fantastic. A lot of work, a lot of thought has gone into those, but couldn't help thinking that where all those red hearts have been put, the most expensive ones. So sometimes I just can't help myself. But hopefully today I'll demonstrate that from my perspective it's all about value rather than cost. Okay. I've worked on quite a few international commissions during my time, but just to give you a perspective of London and some of the key projects I've been working on, and really London is quite an interesting city in that there is quite a large range of tall building typologies there, and they do demonstrate and display a very large range of costs, mainly because the architectural and engineering proposals are so different. So, I mean, I've worked on the HSBC headquarters there down at Canary Wharf in the Docklands area east of London. Fat, functional buildings, generally very cost effective. I drafted the first cost model for the Leadenhall building in the middle there in the City of London back in 1999. The contractor has only just been appointed on that project, so that does demonstrate the large gestation periods that some of these buildings in historic environments like London have to contend with. And lastly, the Shard there, I've been working on that project since 2002, and that is due for completion mid-next year. Interestingly, most people think the Shard is probably one of the most expensive buildings in London because it's going to be the tallest building in Western Europe at 310 metres. It's actually one of the most cost-effective, and the reason for that is its shape. So from my perspective, people ask me about what are the premiums for going higher. Actually, shape is much more important than height. Oops, sorry. Okay, where did it all start, and what am I going to talk about today? Well, it actually started back in late 2007 when I was introduced to IDIS Architects and their advanced modelling group and sustainability group. And what we found was that we had a common interest in sustainability, but also the fact that many parts of the sustainability equation were missing. Most of the regulations, certainly in the UK, are overlapping, conflicting in certain respects, but also don't cover every aspect that you really should consider when you talk about sustainability. And one of the things we wanted to try and understand was, should we get away from this whole focus on short-term profit? And that may seem like an odd thing coming from a cost consultant. I represent developers who build tall because they want to make a profit. Well, actually, there is definite growing evidence that price plays an increasing role in sustainability, and there's arguments about whether there is a green premium on rents and capital values, but what is certainly true is that buildings which don't display some sort of a sustainability credential are suffering from accelerated depreciation. Tenants are increasingly trying to differentiate between buildings and looking at them from a sustainability perspective, but they don't understand and don't have at their hands a complete framework. So where this all started was IDIS ourselves and a couple of other consultants trying to create this sort of complete framework whereby they could make proper decisions. The other aspect being that we shouldn't consider buildings as standalone products, particularly with tall. The taller, more complex buildings have a great impact on their local environment. Tall buildings and the city support each other. So the whole aim of this was trying to not just talk about profit and think about profit, but the people and planet aspects as well, and bring those longer term issues to the fore so that they're considered right at the outset. And one of the things we did 2 or 3 years ago now, was develop together this tall buildings parametric model. This is sort of an interactive platform where we can assess all of the impacts of shape, of height, of geometry, of briefing, specification, not only in terms of capital costs, but also long-term costs and environmental impacts as well. And it was a serious piece of work which took 18 months to 2 years to develop. There is an intellectual property agreement in place between the partners. There's still a bit of a development to go through, in my opinion. But really the point from my perspective is that if you think that all the important decisions on a project, and particularly a tall building project, are made in the first 1% of the program, therefore at that point you should consider all of the impacts of shape and form. Why tall buildings, apart from the fact it's a personal passion of mine? Well, we all know that inherently tall buildings cost more, they're less efficient, and they take longer to get to site and also once on site to build. They also have opportunities in terms of economies of scale, so the sheer quantities involved mean that you can take advantage of those economies, but if you get it wrong, there are some severe diseconomies as well. But surely, with the capital investment that's required for these sort of buildings, all these issues should be considered right at the start. And just looking back, there are 3 fundamental concepts which started 2 years ago, which we've taken forward to a recent study that I'm going to outline in a second. And those are the ability to actually assess a tall building from different value perspectives. The point that actually all the way through this exercise, every single discipline that was involved was actually involved in every decision that was made. And some of these connections between disciplines they're many and also they're complex, and therefore to be able to sit around a table and make those decisions collaboratively was a very, very powerful thing to do. And finally, it's all about long-term improvements. One of the things our industry suffers from is a dearth of data. So what this really does encourage is the collection of data. And there's an initiative in the UK called Carbon Buzz, which has been running for a few years now. And this was prompted by the realization that there was a lack of an appreciation between CO2 emissions and energy use in buildings. But it also tried to close the gap between designed and actual energy in buildings. There's a whole aspect of the way buildings are used and operated, which actually is missing from that design aspect. And the reason for that is that regulations don't require considerations such as operating hours, such as special functions in buildings, such as appliance loads, to actually form part of those initial calculations. One thing I do know lots about is how much these buildings cost. And just going into the next study, which started about a year ago, it was prompted by a developer in London called Sir Stuart Lipton, who's very renowned and has an amazing list of contacts. Stuart's now in his 70s, and he's been around for a long time. And he asked me to go and see him and just explain to him about office benchmarking in London. And this very busy graph just demonstrates and displays the shell and core costs of office buildings in central London over the past 5 or 6 years. I don't expect you to understand it, but one of the key results from just looking at this was the lack of correlation between cost and height. I don't know if you can see it there. That black line there is the height of those buildings, and the cost goes from low to high. So you see there's very little correlation between cost and height in the low-rise section. Back up here, the high-rise, and this is all in terms of number of stories. Again, even within the high-rise group, a lack of correlation between height and cost. And going back to what I said earlier, one of the reasons for that is actually shape is more important, as is specification. And this is a slide I've been showing for many, many years, which at the time looked at the top 9 tallest buildings in Asia and compared them to those array of towers that are going up in London at the moment. And it just shows the difference in wall-to-floor ratios, i.e. the amount of facades that each of those buildings has in comparison to its floor area. So you see in the Asia-Pacific region, generally about 0.3. Most of those buildings in London have double the expanse of facades. One of the reasons for that is that those Asia buildings, whilst architecturally very interesting buildings, are basically extruded forms. They have large floor plates with central concrete cores which are repeated. Whereas the ones in London, and there you go, all these wibbly-bobbly floor plates, with cores all over the place. They have a value, there's no doubt about that. Some have a greater value than others, but they certainly have a cost as well. And then this prompted us to think about, well, how does London compare to the rest of the world? Actually, London's probably the most expensive place to develop a tall building in the world. And we've just started another exercise to really get beneath the skin of that and understand the detailed reasons for that. So on the back of that, Sir Stuart said to us, look, you know, if you look at that, the mean average of those landmark towers in London, about £250 a square foot, I want you to come up with something which is 150 to fit out, so about 125, i.e. half the price. Is it possible? So just to put that challenge into perspective, half the price of a central London high-rise, even about 30% lower than a central London low-rise. How do we do it? Well, we start off by thinking it's about a number of fundamental things: process, form, specification, the ease with which these designs could be built. But we started off with form, because we thought, you know, this is probably the most expensive thing. And this is not a cost consultant design tower. The point of this slide is just to demonstrate that there were some baseline assumptions that we had to make. It was a 40-storey office building in the centre of London, 60-year lifespan, using a British Council for Office specification standard. And that was the answer. By pure coincidence, we came up with two options. One was a rectangular 60 by 45 metre floor plate. The other was this, a 54 by 54 metre floor plate, the exact floor plate of the HSBC tower in Docklands. And the way we did this, we started with the structural engineer and said, look, just come up with a structural solution which involves no complexity, uses standard sections, no other constraints. What do you come up with? And then we sort of repeated that with each of the disciplines and then talked about it and came up with the best fit. But for example, on the structure, 15-metre quarter glass, 6-metre centres for the perimeter columns. We had central plant, fan core system throughout. That structure is actually 65 kgs a square metre. Those buildings in London range between 120 and 200 plus. So even on the structure alone, we were much less than half the price. We didn't get to 125, but we got much closer than I thought we would. Now, this isn't a very interesting building. In terms of the facades, obviously I just were interested in how we could enhance that to make it a bit more appealing and attractive. And we talked about a number of things in terms of whether we could employ different languages on different elevations, horizontal, vertical, etc., where we could split the building between the top, the bottom, and the middle, and various other things. And also whether we could, you know, this is the starting point. This obviously isn't the answer. As we heard this morning, you couldn't build this sort of building in the centre of London, but perhaps you could. You know, this is, you know, everything that goes beyond this bunker scheme, if you like, has to have a value attached to it. So it's almost like a shopping list of value enhancements. You could make cutouts to this building. You could do a number of different things. But even all that, we're only talking about a small part of the profit circle. What about whole life costs? What about people? What about how the building is going to be used? Is it fit for purpose? And what about the planet? What about the carbon emissions from this building? And this is the crux of it. This exercise has actually received quite a bit of press in the UK, but that press has been quite dramatic and focused on cutting costs. Actually, the whole point of the exercise was not about cutting costs. It was coming up with a solution where we could understand what all the sustainability credentials for a building are. And this is, again, another busy chart, but this is something that IDAS produced, what they called a sustainability evaluation matrix, whereby we actually scored a number of fundamental options in the design, whether it's steel versus concrete, chill beams versus fan cores, decentralized versus centralized plant, precast versus curtain walling, etc., etc. And we scored those according to the three people, profit, and planet perspectives. And one of the interesting results was that no matter which perspective you look from, you, without fail, always got a different answer. So, for example, if you were looking at the net area, and developers are very keen on increasing the efficiency of their building and creating as much net area as they can, then, for example, on this one, it was a curtain wall and a steel frame with the answer. But if you then switched to capital cost, actually, precast and short span concrete was better. And if you then looked at whole life costs, well, actually, chill beams are better than fan core units because of their lower maintenance and energy use. The other result was actually looking at some of these longer term issues. the difference between the best and the worst answers was actually quite dramatic. So you can see here a 34% difference between the best and worst performance in terms of embodied carbon. So just going back to this whole point about value perspectives, and this is one of the key learnings from the study. I mean, you can figure out those bottom three for the moment. I mean, because we know that tall buildings can have a value that extends beyond their envelope in terms of the community and brand. So just looking at those top three, well, the exchange value is that going back to that short-term profit, and that's what developers still tend to focus on. But actually, then when you look at life cycle value, future costs actually outweigh current capital costs. Then if you look at operational value, well, actually, between 80 and 90% of a building's total cost over its 60-year life is in the people who use it, in salaries and associated costs. Therefore, when we're talking about an investment decision on a tall building, shouldn't that be factored into that initial design and other considerations? You know, the global economy is a hyper-competitive place at the moment, but it's also extremely transient. And the way office buildings are used now is very different to what how they were used 10 years ago, and it will be different in 10 years' time. Again, you know, on my office where I work at the moment, we're going through a restack at the moment. We're going to be configured in a much different way with much more breakout space, flexibility. It reflects actually that some people work earlier in the day, some later. You know, office is more event rather than daily conditions now. So one thing we didn't do is actually put different weightings on those different values perspectives. We could do if we wanted to, but you know, there wasn't an answer. There's no obvious answer. The point of the exercise is that there are a number of parts to the jigsaw, and not all of those parts of the jigsaw are looked at the moment. And at the end of the study, we actually invited Peter Rees, who is the Chief Planning Officer for the City of London, who's been in that role for 25 years or so now, a very powerful man, and in many ways responsible for the sorts of buildings that are going up at the moment. Some people would unkindly say that these sort of towers, these landmark icons, are perfume bottles. They're there because it's part of, as David Scott said this morning, shape making. And where shape making is done for the sake of it, then that's not a good thing. They obviously have a value as well. You look at Swiss Re in London, the Gherkin as it's called, you know, that would never have been built speculatively, one of the most inefficient buildings in London, but it has an inestimable value beyond its site confines. You know, everyone without fail loves that building. It has a value to the City of London. But the point is, what about the other 95% of the building stock? So what we would like to do is actually develop this study a bit more, validate and develop the model, refine it in some ways to consider some of the things that we haven't really done at the moment. Look more at global comparisons, learn lessons from around the world. And we started that with our friends Tishman in New York, where we're actually doing a detailed exercise comparing New York City with London at the moment, and the reasons for the cost differences there and the product. Also look at innovation. In this part of the study, we didn't look at innovation in terms of materials, components, methodology. I mean, one thing I would like to do is involve a contractor or two in this and just understand what it means to them, because one of my sort of hobby horses is that, you know, some of these prices that for some of these buildings, very, very expensive buildings, the risk that is priced by contractors is not only explicit, it's implicit as well. So, you know, risk will fall out if you can actually sell a building to the industry. And most presentations these days tend to talk about building information modeling. There's no point in producing a great creative design if it's then wasted through a lack of coordination, you know, through sort of sharing of 3D information, and then BIM, I'm nearly there. BIM does this, but BIM is actually different to parametric models. What we're suggesting is that you need the parametric model to bring forward all those considerations right at the beginning so that you optimize the concept, but at a place in the process, then BIM is appropriate. And we do understand that actually it's not just about the buildings, it's about the spaces in between them. And Chicago does that wonderfully well. And lastly, I'll just go back again to those three concepts because I think they're equally applicable now to when they were 2 or 3 years ago. You know, the point about just looking at the different value perspectives, key one for me, doing it all collaboratively, and also just thinking about the long-term performance of a building. The government in the UK produced this low-carbon construction report recently, which everyone is focusing on, which is all about reducing the carbon, but it actually also recognises that decarbonisation isn't the only measure of sustainability, and in that respect there is some resonance with the study that we're undertaking. And I'll leave it there. Thank you.
Thank you, Steve.